So thank you very much for coming for the Hubble Space Telescope Town Hall. You're here to the bitter end, and we're glad to have you here. We're very excited, and I think the whole community should be excited that this marvelous telescope has lasted through to this year, and this begins the 25th year of Hubble Space Telescope operations. Who knew? It's done an amazing amount of science. It's really transformed a lot of the way we do science as well as our thinking on many topics. And so today, as part of the anniversary here at the kickoff proceedings at the AAS, we started with some great press releases, beautiful imagery, and now with the town hall, which is being recorded for posterity, and also if you'd like to share with your friends that we did record this and we will put it on YouTube so it can be viewed later by those who were not fortunate enough to be here. In this town hall, we're going to have three speakers. First, Ken Sambach from Space Telescope, who is the Hubble Space Telescope mission head. And he's going to review a little bit about where we are with HST and its bright future. Then we're going to have Jennifer Lotz, who's from Space Telescope, who's going to talk to us about our major effort of large observation for the frontier fields. And she's the PI of that program. And some really beautiful data and fantastic results have come out of that program. And then Amber Straw from NASA headquarters is going to talk to you about the 25th anniversary celebration, the year of activities that are ongoing, and how you can participate. And I will let each speaker hand off to the next. And then at the end, we will have ample time for your questions and discussion. Thank you. So first off will be Ken Sambach on what about HST today and tomorrow.
Thank you, Carol. So yeah, today I'm going to tell you a little bit about where we stand with the observatory today and where we're heading in the next few years. And the punchline is this: Hubble is just doing beautifully. It's as powerful as ever. We have excellent imaging and spectroscopy capabilities. We're still doing coronagraphy and astrometry with the telescope. And the observing program is addressing everything from exoplanet science to the architecture of the universe. The science that Hubble does cuts across NASA's main science themes, and as always, Hubble remains a great observatory, multi-purpose, and in wide demand by the observing community. You probably saw this beautiful image on Monday when it was released. This original image of the Eagle Nebula was taken 20 years ago now. Our Wide Field Camera 3 has re-imaged that field, both at visible and at near-infrared wavelengths. And you can see how remarkable that field looks both in the visible with a wider field of view and in the infrared, where you can see deep into some of these pillars of star formation. Many of you have probably also seen the tremendous M31 mosaic that's outside the other hall that we have conference talks in. That image is the largest image ever produced by the observatory, both physically printed by the observatory, as well as the largest mosaic we've ever made on the sky, and that was done by Julianne Del Canton and her folks here at the University of Washington, so it was very fitting that we were able to bring that mosaic here to Seattle. Take a look at that. Get your nose up close to that particular image. There are 100 million stars in that image resolved. It's amazing. Hubble's science output continues to be extremely good. This past year was another excellent year with more than 800 papers published based on HST data. We're running right around 800 papers a year or so for the last 4 or 5 years. There have now been almost 13,000 papers published to date based on HST data. And an even more remarkable number is that almost 13,700 different people have published or had their names on HST papers. Think about that for a minute. That's bigger than the size of the AAS for sure. And so, Hubble is definitely touching generations of astronomers. There have been more than 500 PhD theses based on Hubble data, and right now, approximately 40 or 50 people a year have PhD theses published that are based on Hubble data. Overall, the observatory is doing extremely well. The science instruments are all healthy and operating. The advanced camera for survey and the wide field camera 3 both have charge transfer corrections in place for their CCD cameras, which is great because it means that we're actually able to roll back the aging clocks a bit on those cameras. The cosmic origin spectrograph sensitivity is still very, very good. We now have very blue modes that get down well below Lyman alpha. The Space Telescope imaging spectrograph is operating well, and as I said before, it's being used for coronagraphy as well as spectroscopy and imaging. On the main systems of the observatory, those are also working well. 5 of the 6 gyros are available for use. We lost 1 gyro back in March of last year, not a surprise. Gyros are not a life-limiting factor for this observatory. We know how to run in a reduced gyro mode should it be necessary. Overall, the thermal control, the data management systems, and so on are all in excellent health. One interesting tidbit, 2 instruments were repaired during the servicing mission 5.5 years ago, the advanced camera for surveys and the Space Telescope imaging spectrograph. Those failures that originally occurred were electronic in nature. The astronauts installed new electronics in both instruments. Those 2 new instruments have run now on those newly installed electronics longer than they ran on the original electronics. That's very encouraging because it suggests that the instruments have outlived their infant mortality period. So it's quite possible, even though we originally thought those 2 instruments might not last more than 5 years, they may actually last considerably longer than that. We'll see. In looking forward, the mission has put together what it calls a 2020 vision for the observatory, and that 2020 vision is very straightforward and simple. It's to operate the observatory out to 2020 or beyond so that there's at least a year of overlapping science observations with JWST. And that's going to be performed in a manner that maximizes the science return of both observatories, takes full advantages of HST's unique capabilities, and really addresses the community's scientific curiosity and engages the public in scientific discovery. Let's think about that for a minute. If we operate out through the end of fiscal year 21, which is cycle 28, we're currently in cycle 22 right now, that's about 7 cycles of observations. At about 4,000 science orbits per cycle, 4,000 hours per cycle, roughly, that's 28,000 orbits of science remaining. And for comparison, we typically have about 20,000 hours or orbits requested each cycle. There's clearly no loss of things or lack of things to do with this observatory in its remaining years. The question is, what do we do? And so we've put out a call for HST 2020. There's an extra 2 in there, isn't there? You never know. You never know. We put out a call for vision white papers, short white papers from the community, just asking, what is it that we should be doing with the observatory over the next 5 or 6 years that would enhance the scientific legacy? Those are due February 20th, and the submission details are there. Those papers can address any aspect of the Hubble program. So I'll put forward a couple of questions to you. Are there specific programs we should be undertaking now in preparation for JWST or during the period of overlapping observations? What types of synergies might be available? We'd like to hear your thoughts on that. Are there other observations from ground or space-based observatories that should be more closely linked to HST observations over the next few years? Should we have some kind of a reciprocal observing agreement like we do with NOAO or NRAO, for example? Are there science questions that should receive greater emphasis over the next 5 years? That's kind of a loaded question, but we'd like to hear your thoughts on that. And, of course, your rationale for why that should be. Should we devote a greater proportion of observing time to specific purposes? And one that I mentioned earlier, should we be putting more emphasis on making sure that students can finish their PhDs or use Hubble for their PhD theses? I think that's a great question to ask the community. Should we make a special effort to optimize the observing program for transient phenomena in the area of Pan-STARRS, LSST, transient phenomena are going to be leading to all kinds of discoveries. Should we be doing something with Hubble to optimize the science return from those kinds of observations? And given that Hubble's lifetime is finite, are there changes to the time allocation committee that maybe we should make? Not that it needs to be made, it runs well, but maybe there's something that we could do to enable quicker responses to new discoveries. Is there something that we should be doing? Let us know. So we have a call for proposals out now. That was released yesterday. The proposals are due April 10th. Their key features remain from previous calls. So the Ultraviolet Observing Initiative continues. The medium proposal category continues. The frontier fields, which you'll hear about in just a moment from Jennifer, continue. And we encourage people to submit archival and theory and general observer proposals, specifically that develop the scientific landscape for JWST and help maximize its scientific return, or can exploit the potential of those frontier field programs. We'll be talking with the community some more about this at our May symposium at the Institute in April. That's the symposium devoted to looking not only back at the extraordinary impact that Hubble has had on science, culture, and society, but also looking at how we can craft a real scientific legacy for the mission and to focus on what we should be doing in the coming years. So in addition to the white papers, this will be another place for people to convey their thoughts to us, which would be great. Now, each year, we do about 40 press releases or so. This is just a kind of an eye chart, and you just look at the bars on the chart and notice that the y-axis is millions. And this is the potential circulation of the media outlets that pick up Hubble results. So we typically measure those in hundreds of millions, and you can see that some things really capture the imagination of the public. I understand from our press people yesterday that the Eagle Nebula and the M31 images that were released at the AAS this week will probably be somewhere up around the 500 or 600 million mark on this particular kind of plot. So with that being said, let us help you communicate your science to the public. Alert us to the newsworthy science results that you have, and let's get your science results up onto that chart. I have one final slide, and that is the HST budget. Here's the budget breakdown between grants and operations both at the Institute and at Goddard. You can see it's roughly a third. I show this for one reason, and that's to let you know that a fair fraction of the money that's spent on Hubble actually goes out to the scientific community directly in the form of grants. And we're committed as a mission to make sure that that continues. We very much like to see something on the order of $28 to $30 million a year from the mission budget being put out to the community directly in the form of grants that help support getting the science out to the public and to our scientific colleagues. So I'll leave you with one final slide and a thought from John Bacall, late John Bacall. We often frame our understanding of what the Space Telescope will do in terms of what we expect to find, and actually it would be terribly anticlimactic if in fact we find what we expect to find. The most important discoveries will provide answers to questions that we do not yet know how to ask and will concern objects we have not yet imagined. I suspect that will remain true throughout Hubble's lifetime and will almost certainly be the case in the next 5 years. Thank you.
Okay, so it's my pleasure to talk to you this afternoon about the Frontier Fields, a major initiative using directors' discretionary time to try to peer deeper into the universe than we ever have before. So I'm acting as the PI of this program on behalf of Mount Mountain, and I'm very privileged to work with a dedicated and talented team of people at Space Telescope and the Science Spitzer Center. So the image in the background here is one that we all know and love and has become iconic. But more than being a beautiful image, the Hubble Ultra Deep Field has really transformed our understanding of the history of the universe. And in fact, it represents a huge investment of Hubble time. So as this version of the observations, the infrared observations of the Hubble Ultra Deep Field, were wrapping up, the director of Space Telescope Mountain asked the question, could we top the Hubble Ultra Deep Field? Can we peer deeper into the universe with Hubble before the launch of the James Webb Space Telescope? Is there exciting deep field science left to be done with Hubble in its remaining years? So he posed this question to a group of astronomers. And of course, when you ask them, could they do interesting things with lots of Hubble time, the answer is usually yes. And the answer they came back with was to use a trick, use gravitational lensing, that is nature's telescopes, strong lensing clusters, plus Hubble to peer deeper into the universe than we have before, using less exposure time. And they proposed not just looking at one strong lensing cluster, but to look at 6, and to turn on both of Hubble's primary workhorse cameras and use those in parallel so that you would get 6 lens fields in addition to 6 blank fields. And this would add up to an exciting new parameter space for exploring the distant universe. So the primary science goals of this program, as outlined by that science working group, are firstly, simply to see deeper than we have before and to probe those galaxies that are intrinsically fainter than anything we've seen, and those galaxies that we can see at times before and during the epoch of reionization. And by going this deep, we would be able to trace the early star formation histories of those galaxies small enough, faint enough, to be the early progenitors of our own Milky Way. Of course, gravitational lensing not only makes things appear brighter, but it stretches them out. And so we would have the opportunity to study these galaxies with greater spatial resolution than possible with Hubble alone, looking at their resolved structures, their colors, their sizes. And some of these galaxies may be boosted enough for ground-based spectroscopic follow-up. Finally, with 6 lens fields and 6 parallel fields, we could build up a better statistical picture of galaxy formation at early times. So this slide is my one-slide summary of our observing program. All of these observations with Hubble are being done with director's discretionary time. And so for each cluster parallel pointing, we are dedicating 140 HST orbits using both the ACS optical imager and the wide field infrared channel in parallel, obtaining optical and infrared images in 7 bands going down to 27th magnitude. And our observing plan is such that we're looking at 2 of these clusters per year spread out over 3 years for a total of 840 orbits. Now, Spitzer has also dedicated a major chunk of its director's discretionary time, and so for every cluster and blank field pointing, there will be exceptionally deep IRAC Channel 1 and Channel 2 imaging. And all of this data is public, the raw data is public, and we're working very hard at Space Telescope to produce high-quality science images as well. So these are our 6 frontier fields, the clusters. And these were selected in consultation with the community, primarily based on the known lensing strength at the time, but also on based on their location in the sky, how dark was the background, and whether or not there was any ancillary data available. And I'll just highlight our last 2 clusters. Recently, these were approved, and we'll be going forward with the observations for these in cycle 23. And I recommend you take a look at the call for proposals that went out yesterday for more details about how to use these for your science. So this is a beautiful image which may be familiar to you. It's been shown a few times around at the AAS meeting this year. This is our first cluster, Abell 2744. All of the data is in hand for this cluster. You can go to our website, get the raw data, get the reduced data, get lots of beautiful images. But I also like to show an amped up version of this image. So this is the infrared version of Abell 2744 with the stretch maximized to show just how deep we're really going when we look at this cluster. So if you're a cluster scientist, you'll see we've got lots of intercluster light. You can see the tidal features of cluster galaxies that are interacting with each other. And if you were to zoom in very close in this image, you'll see we're also finding lots of little faint red galaxies in the background, which of course is one of the primary goals of this program. To interpret this image, you need to have an understanding of the optics of the cluster. So we've gotten a number of modelers from the community to provide us their best models for the maps of the dark matter and the lensing strengths of these clusters. So shown in blue, overlaid in blue is an estimate of the dark matter mass distribution in the cluster, and in red is the critical curve, so those areas of highest magnification. So background galaxies that fall behind those critical lines can be magnified by factors up to 10 or even 100. And it's along those red regions where we are getting the deepest ever views into the universe. So we've been going along here for over a year now, and I'm pleased to say we have some very exciting science results. We have, in fact, detected one of the most distant and intrinsically faintest objects. So this is a redshift 10 galaxy candidate, which is triply imaged by this cluster. And so one of the reasons why we think this is such a secure candidate for a redshift 10 object is not just the fact that it has extremely red colors, but where it lies relative to those critical curves. Its positions in this image provide further evidence of it being at an exceptionally high redshift. So this is our second cluster, MAXO 416. All of the data for this cluster is also in hand, available online. And these first two HST frontier fields and their parallels have really been a success. They've dramatically increased the number of intrinsically faint galaxies known to be in the first billion years of the universe. Why is this important? Well, this is a result from a very recent paper looking just at the first cluster, Abell 2744. This is a redshift 7 UV luminosity function. I show with a black arrow the limit for the Hubble ultra deep field, and you can see we're going several magnitudes fainter than that. One of the reasons why, we're not just collecting little faint galaxies, this is actually quite important, because understanding how many faint galaxies there are can help us count up the number of photons that could contribute to the reionization of the universe at this epoch. So as we go forward and we collect the rest of the clusters, we'll be able to place incredibly good constraints on the slope of the faint end of the luminosity function during the era of reionization. Of course, there's lots and lots of other science that can be done with these images, and I think that's one of the more exciting aspects of the program. It's not just redshift 10 galaxies that are interesting. Galaxies at cosmic high noon at redshifts 1 to 4 will also be magnified and stretched, and we can do groundbreaking science with those images. The clusters themselves will be, can be studied in great detail. We'll be able to map out the dark matter and the substructure within those clusters to unprecedented levels, study the cluster galaxies, the dwarfs, and the intracluster light. And some of the most exciting science is coming out of the transient science, looking for supernova in these fields. And there are lots of other things ongoing. I'll just note that we have 3 GEO programs that are getting ancillary data on these clusters in the UV. With the WIFC3 IR GRISM, and then Steve Rodney's program, which is a TOO program to follow up any exciting transients. And there's something like 10 or 11 HST archival and theory programs from cycle 21 and 22 that are dedicated to doing science with these data. And so I encourage you to look again at the call for proposals and think about what you might want to do for cycle 23. I mentioned dark matter as one of the things that you can do. And these data are also going to be transformative in our understanding of the dark matter distribution in clusters. The fact that we are going so deep provides many multiply imaged galaxies, which allows us to map out the dark matter to unprecedented resolution and precision. And so this is a map of the dark matter distribution made by Matilda Jauszek last year. This is our third cluster, MAX 0717. We're about halfway done with this cluster. This image is of the ACS Optical. We're going to start getting the WIFC3 IR in a few weeks here. As of yesterday, we're officially halfway complete with our frontier field observations. And as I said, those last 2 clusters and parallels are approved for next year's observations. So this is the cluster that we were getting data for yesterday, MAX 1149. We completed the WIFC-3R observations. We'll start again in April with ACS. The background image here is beautiful, but not quite as deep as our frontier fields will be. This is taken from the CLASH survey of a few years ago. And I'm just going to zoom in here on the center of this cluster and sort of highlight this spiral galaxy in the middle. So this is a spiral galaxy that's a background galaxy behind the cluster. One of its arms is being lensed by that little red cluster galaxy in the middle. And this object has been a source of one of the most unexpected things I think is coming out of the frontier fields. So for any of the press in the audience, this is embargoed, but I just had to share these images. Steve Rodney talked about this yesterday at the Frontier Fields Hyperwall. So this object, I said, this cluster was observed in 2011 as part of the CLASH program. GLASS, which is the GRISM program, went back in November, and the supernova team, including Patrick Kelly and Steve Rodney, were looking at these images, and bam, up popped not one, not two, not three, but 4 images. And they were incredibly lucky because we were about to start our 7-week observing campaign, getting 70 orbits on this cluster shortly thereafter. So this object is actually the first detected multiply image supernova. They've christened it Supernova Refstal after the seminal paper. But that's not all. So the arm of the spiral is being multiply imaged by that little red galaxy, but the spiral galaxy itself appears multiple times as well. So there are 3 more images of that spiral arm in this cluster, and we think that supernova may have appeared several times before and will appear again. So the light from this supernova has traveled or will travel 7 separate paths around max 1149 on its way to Earth. So just to summarize here with the ways that you can use this data, as I said, we have the raw data, the science quality data, and lensing maps are all public on MAST and on our website. We're done with the first 2 clusters. We're halfway through with the second 2 clusters, and they're breaking new frontiers left and right. We had a successful midterm review, and we're going forward with those last 2 clusters in cycle 23. And we're also thinking about providing additional funding opportunities for updating and improving the lensing models. I didn't have any time to talk about Spitzer and Chandra, but the Spitzer IRAC observations for those last 2 clusters are underway. Chandra, there's lots of observations being done by Steve Murray and by Christine Jones-Foreman. And in August at the IAU, there will be a several-day workshop highlighting the frontier fields. So thank you very much.
Okay, well, the 25th anniversary of Hubble is obviously a huge milestone, and we have an entire year of activities and events and programs planned, starting really here at this meeting. You've all seen all the great press that's come out, all the hype on social media from the release of the images this week. So things are really kicking off this week for this year of celebration. So I just wanted to highlight some of our high-level plans and some of the specifics that we have going on in the next year to celebrate Hubble's 25th anniversary. So at a high level, we're sort of going on the broad basic themes of celebrating this past quarter century of discovery and inspiration, and really the effect on culture that Hubble has had. And we want to not only look to the past, but we want to also emphasize that the Hubble is going strong. We expect it to last out till 2020, maybe longer. And then, of course, emphasize Hubble's successor, JWST. And again, sort of taking advantage of the fact that Hubble has really infiltrated our culture in all these different realms. We want to get out that message and be really promoting the idea that Hubble is the people's telescope. It's not just a tool for astronomers, that it's something that the public, that our society can celebrate. And we also want to talk about how Hubble is a human story. The science that we do, we people do the science. And in addition to that, of course, Hubble has the great legacy of having had astronauts go to service it. And that's a story that really resonates with the public. And so we really want to emphasize the human side of Hubble all along through the next year. And so at any time we're doing these sort of outreach communications plans, we take an audience-based approach to make sure that what we're getting out is appropriate for the different audiences. We really want to celebrate and engage what John Grunsfeld calls the Hubble generation. So this generation of people 25 and younger that have grown up with Hubble always having been in space. And so we really want to emphasize on to that generation in our outreach events. So we have a whole year events and programs and products, and we have, of course, along with the specific discrete events, we have a really robust social media and traditional media outreach plan, which again has already started really in earnest this week. Our audience-based approach is what you would expect. Of course, we are celebrating and really trying to get the message out about the team that built Hubble and the teams of scientists that have used Hubble over the past 25 years. And of course, the public is a big target of our outreach, as always. We really want to focus on getting to non-traditional audiences. There's a whole host of people out there that are already big NASA fans, and we're glad about that. We're happy about that. But we want to reach into some more audiences that might not already sort of be our fans, and try to reach out to them and to get them engaged in the Hubble celebrations. And then, of course, we have a very robust plan to reach out to teachers and students in the classroom, which the Space Telescope Science Institute has a really great, an excellent team that has been doing that for many years already. And so we're just going to incorporate Hubble 25th into all of the great things that Space Telescope does over the next year. And then, of course, there's our external stakeholders, our friends on Capitol Hill, and our corporate partners that will be involved in a lot of these things as well. This is all a big collaboration between NASA, ESA, obviously the Space Telescope Science Institute, and then our external partners also have a big role in a lot of our events as well. So I want to tell you about some of the specific things that we have planned, and this is just going to scratch the surface of everything. And just keep in mind, again, that everything that we do is going to be amplified by traditional and social media. So the first big thing, of course, is a celebration event at the National Air and Space Museum in Washington, D.C. So we have the evening secured on April 24th, which is, of course, the launch anniversary. And so that will be a large event to celebrate the launch. And in addition to that event, IMAX has confirmed that they're going to re-release Hubble 3D in the month of April of this year. So if you haven't seen that, be sure to check out your local IMAX, and it's a really great film. So one of the things that we wanted to do for that event, obviously only a certain number of people can attend it, so we are planning to webcast that event and then have science centers, planetaria, and all the NASA centers sort of host their own satellite sort of birthday parties for Hubble around the webcast, and then kind of put their own flair on whatever they want to do to have their own localized event. So we're envisioning, a nationwide and even a worldwide celebration on that day of the launch anniversary. So in addition to that, all the NASA centers are engaged in the anniversary, and they all have their different sort of spin that they'll put on Hubble. A lot of the centers have, besides Goddard, obviously Goddard's a big center, but many of the NASA centers had parts in the development of Hubble, in the engineering especially. So we're getting all the NASA centers engaged, and they have their own sort of events planned in addition to the April 24th sort of keystone event. We're working on a big event the next day on April 25th, that's Saturday, at UVOIR. Many of the astronauts, the servicing mission and deployment astronauts, will be in town for the event on the 24th. So we wanted to take that great opportunity while we have all the astronauts in town to come up and have a big public event. So we're working with the Smithsonian to plan a big public event on that Saturday, the 25th, out at UVOIR with the astronauts. So that should be a lot of fun. And we'll also look into the possibility of doing some webcast of that event as well. New York City is very interested and already involved in many ways in celebrating Hubble. And there's so many, there's several different museums, which most of us are familiar for, the American Museum of Natural History. There's the Intrepid Museum. The World Science Festival takes place every summer in New York City. And so there's all these different groups that are all interested and have already started to contact us at NASA about how they can be involved in celebrating Hubble's 25th anniversary. So we're working on tying all those pieces together and really having a big celebration in the month of April in New York City. So we did have something that has already happened in New York. On New Year's Eve, we had the Hubble video, which I'll play for you in a few minutes. It's a sort of a teaser video. We had that played on the big Toshiba screen in Times Square on New Year's Eve, where there were so many people gathered there. And Mike Massimino gave a little short talk on the webcast of the New Year's Eve celebration. So we've already had a really good event happen in New York City, and we're looking forward to other events in the coming several months. So in addition to New York, there are, of course, museums, planetaria across the country that are planning different celebration events. And in particular, I mentioned the Intrepid Museum in New York City has already opened up in October an event dedicated to the Hubble 25th anniversary. So the next time you're in New York, check that out. It's a really beautiful exhibit. It'll be up through next fall. There was a panel there in October in November with the servicing mission for astronauts that was really well attended, and that was also videoed and replayed on NASA TV. And of course, we'll work with the NASA headquarters, Office of Legislative and Intergovernmental Affairs, and our industry partners to engage all our external stakeholders in a lot of the events that they already do. So the NASA Day on the Hill and those sorts of events. So we're working with them to plan those things as well. One really great way to reach out to some of the non-traditional audiences I mentioned is in these big public events that happen. So one good example is South by Southwest down in Austin, and that happens every March. So the last few years, NASA's had a very big presence at South by Southwest, and this is an audience that is very tech interested, but not necessarily space interested, and so they love it when we show up with NASA stuff at South by Southwest. And so we're going back again this year. We have a panel in the interactive session on Hubble 25th, and John Grunsfeld's on that panel. And we have a big NASA exhibit that we're going to have Hubble 25th content at. We're going to take the big, the Andromeda mosaic down to that. So a lot of really exciting things for different large festivals that happen across the country. And I already mentioned World Science Festival, and there are several other sort of events like that across the country that we're going to be doing over the next year. We're excited to have secured exhibits in the Dulles and Reagan airports, and this is just some concepts of what that might look like. And we're also reaching out to BWI and to some other airports across the country as well. And Space Telescope is leading that effort. But so next time you fly through one of these major airports, look out for Hubble because it'll be there. There'll be a nationwide university lecture series going on through the month of April, and we're still working on that slide deck for that. And so get in touch with us to get slides, to get support material for that. Of course, the Hubble 2020 symposium that's coming up in April. And then really just other events, of course, AAS, which we're at right now, and other scientific meetings throughout the year. Space Telescope, again, has an excellent team that's doing formal and informal education. And so there's a whole host of education programs going on throughout the year that all focus on Hubble 25th. I've already mentioned several times we have an extensive traditional and social media outreach plan. We have a really a willing audience on social media, and so we really hope to leverage all our different accounts. The @NASA Twitter account has 8.5 million followers, just to give you an example. And so we we'll work with all of the different partners and our corporate partners to really have a really consistent year-long presence on social media, Twitter, Facebook, and all the other platforms. And then the traditional media, of course, is also a key part of this. There will be Hubble 25th specials on National Geographic, and NOVA is also doing a documentary. I already mentioned that the Hubble 3D will be re-released on IMAX. And then ESA is leading an effort to get planetarium shorts distributed throughout Europe and also throughout the U.S. So that is another really exciting thing that will be happening across planetaria across the country. And then Space Telescope is also doing 3-minute videos that they're going to be releasing every month, and the preview for that's already out. So be looking for that. One thing I haven't actually put in my slides, but the place where you can go to find all of this information that will be constantly updated is a website that we have dedicated to the 25th, and that's hubble25th.org. So it's hubble25th.org. And so all of this information and ways to get involved for you all to get involved in this will be available there. And of course, you can always get in touch with any of us to find out details as well. So I'm going to leave you with the video that the NASA TV folks at headquarters made for us just a couple months ago. And I'm going to go ahead and play that now. And fingers crossed that the sound works.
Thank you to our speakers for these great presentations. And now, we have a couple of minutes. If you'd like to ask a question, please make your way to a microphone and think not only of a question that you'd like to ask, but maybe somebody out there in the community who'd like to ask a question, and you can do that on behalf of them so that when we play this back, they'll have the answer. Anybody? Don't be shy. Okay, we've got a very shy audience. Okay, great, Martin, thanks.
Hey, Carol, thanks. I was at the Science Writer meeting that was done yesterday, and I was kind of curious. There was an emission, and I'm kind of curious what is happening with COS. It's such a powerful instrument. There's a lot of science and interesting stories coming out. Could somebody tell us something about the cosmic origin spectrograph for telling what Hubble is doing?
You'd like to hear about what kind of science is coming out? Is that the question, or is?
Well, when COS was installed, there was a lot of interest in what it was going to do, but most of the public stuff that is out there is imagery, right?
Right.
But I'm wondering if there are stories in there for science writers or communicators like me in planetariums and things that we can really highlight.
You asked the right person because it's a strong advocate of the COS science.
Yeah, I'm a spectroscopist by training, so that's an instrument that's near and dear to my heart. COS is touching all kinds of interesting subjects. We've had several large programs over the past few years devoted to understanding the material out of which galaxies form, the circumgalactic medium and the intergalactic medium. And there's great stories there about how, the universe evolves and that structure out of which galaxies form evolves. You've probably seen some of that. The press update that Andrew Fox gave on Monday was just a little snippet of that, and there's a much bigger picture there, much bigger context. COS is doing really great things in the exoplanet area, looking at the atmospheres of exoplanets and detecting heavy elements and different kinds of species in the planets that are essentially evaporating these hot Jupiters. There's lots of interesting observations of hot stars, active galactic nuclei, material funneling into black holes. Just about every area that you can think of, COS is touching in some ways. It's unfortunate that oftentimes, because it's a spectroscopic result, it doesn't get put into a context that's easy for the public to understand. And Carol knows this. I keep bugging her about this, and our other folks in our Office of Public Outreach to try and make that case better, make it easier for you and other science writers out there to convey those interesting science results. So one of the things that we've started doing is including some of the spectra from COS and STIS in the material that we release with press releases, and we're going to continue to do that. That's incredibly important because James Webb is a spectroscopic machine, right? It will certainly produce beautiful images, but it's going to produce a boatload of spectroscopy, and most of its science is going to be spectroscopy related. So thanks for asking that question. I'd be happy to talk with you more individually, one-on-one, about some specific suggestions.
And now that you've asked that question, I'm going to be emailing you and your colleagues about how to help us convey that information, because we often get these results and we're working with the scientists to get their results forward, but we do need to be able to convey that information to the public. So we have a question here and then a question here. So
when Hubble was launched, I was about learning to read or write. But I understand that, some instruments in Hubble have been changed, but the things Hubble has apparently done very well in the past is images. But let's say with the Gemini planet imager, and so ground-based AO has almost caught up with Hubble. Do you see a trend to spectroscopy or trend to UV in the proposals, which are areas where there's no ground-based machine or no ground-based telescope will ever be able to do that?
It's certainly good to encourage things that, people to propose only things that Hubble can do. And like you said, UV spectroscopy of things of that nature is something that only Hubble can do. And when Hubble's gone, there won't be a resource, at least in the near-term future, to do that. Hubble is still extremely competitive with even 8 and 10 meter telescopes on the ground from an imaging standpoint, both from a resolution and sensitivity standpoint, but also from a GRISM spectroscopy standpoint. The Wide Field Camera 3 GRISMs, we can go deeper with those GRISMs than you can possibly go from the ground now. That era too will end with the advent of extremely large telescopes. But for now and at least the next couple of years, Hubble should be very competitive with ground-based observatories, synergistic certainly with some of the things that ALMA is doing, and still have a lot of discovery space available to it.
yes, your question. Thanks for
Hi
your
there.
patience.
Yes, I'm Greg Rodnick from the University of Kansas, and I want to ask a question about the celebrations about the 25th anniversary. Many of the activities are New York City, Washington area airports, but there's a distributed interest across the entire country. And so my interest was piqued partly by your university lecture series, so I'd like to hear a little bit more about what that is, but I'd also like to hear about what kind of efforts are there to extend the celebrations to institutions, For example, all across the country. For example, one of the largest amateur astronomy organizations in the country is in Kansas City. There are astronauts spread all around the country. We have a few in Kansas. Steve Hawley's actually, his office is next to mine. So, I'm curious what efforts there are to tap into those resources, or will all those people be flying to DC for the anniversary? And so we'll miss that opportunity.
So I mentioned, is this on? Yeah. I mentioned the event on April 24th that we're doing will be webcast, and we have someone that is going to be like the point person for coordinating and helping to distribute materials and information to sort of host their own celebrations that day. So she has a list of 200, science centers, planetaria. It's more focused on sort of museums, but also the university lecture series that will be going on during that month that you mentioned. That's also a great way to get involved. So the website that I mentioned will soon be hosting materials that you can go and download or use, and then we'll also find ways to facilitate sending materials to people who want to do things. So those things are definitely being planned. So anyone can get in touch with us for help and for materials to sort of make your own sort of celebration. And we're working closely with the astronaut office at NASA in order to, like you said, to sort of take advantage of the fact that a lot of the Hubble astronauts are sort of spread out across the country. So yeah, we're definitely thinking about those things. But yeah, get in touch after the fact if you want more details or to be to lead an event or anything like that. Thanks.
Thank you very much.
Thank you. Question over here.
Hi, I liked your slide on the status of Hubble and the fact that the gyros weren't going to be a foreseeable issue. But I heard from a friend of an engineer that the most critical component, or the one that they're most concerned about, is actually the solar panels. But I didn't see that on your slide. And did I hear incorrectly from my friend of the engineer, or can you give me an update on that?
At the moment, the electrical system on Hubble is extremely good. I know of no issues with the solar panels. The solar panels do slowly degrade with time. We have not had any issues with them in the last 5 years or so. The amount of power that they're able to produce is declining with time, but it's not declining rapidly enough that we would have to shut off an instrument, say. Honestly, I think unless there's some kind of a catastrophic failure, a meteorite hit, or some kind of a catastrophic electrical failure, that the solar panels are not an issue. It'd be interesting to know exactly what your engineer friend was thinking about.
Oh, as a friend of an engineer.
Yeah, a friend of an engineer. Okay. Yeah.
Thank you. Do we have a? Okay. Oh, okay.
The same
All right.
question?
The very
You heard-
same question. Wow. Oh boy, there's a rumor going around. No problem with the solar panels, folks. Batteries.
The batteries are in really good shape. We've got about 500 amp hours of charge capability with those now. That's still up well above what we need, and so they were replaced during the servicing mission as well, and they're performing beautifully.
Well, let's thank our speakers again, and thank you for coming to the town hall.
Oh, we got one more.
Oh, we have one more question. Sorry.
So I think it was a few months ago that a very interesting paper by Neil Reed appeared in Astro PH, and I'm just wondering if anything is being done to mitigate the problem that he pointed out exists statistically in the proposal reviews.
Sure, I'll take that. I'm part of the Science Mission Office. So the study that the speaker is referring to was an analysis of the success rates of female and male PIs over the history of HST's TAC process. And every year there is a very, very small, but really there, difference in that women PIs are underrepresented relative to the male PIs. And when you add that up over the 20 or so TACs, it becomes apparent that this is a real trend. This happens every single year. So we're aware of the problem. We don't really know how to fix this. Last year we tried an experiment where we removed, we took the names of the PIs. We only included the first initials so that people didn't necessarily know whether it was a male or female PI. We also put the names on a second page, and we labeled the proposals by number and not name. And we instructed people to discuss the proposal and not who the PIs were. That didn't seem to make a big difference. So we're going to continue to investigate this problem. The other thing that we do at the start of each TAC, during the orientation, is that we remind people about the issue of unconscious bias and make sure that all the panelists and the TAC chairs are aware that this is a real issue when you're discussing proposals and female versus male PIs. But you know, we're aware, we're doing the best that we can, I would say.
Is there any study, is this off?
Yeah.
Is there any study that's going to be done about whether there's institutional bias?
You mean at the level of, can you ask about, can you clarify what that means?
I can clarify that because I was at an institution 16 years ago, and one year I submitted 3 Hubble proposals, and I had 3 Hubble proposals accepted, which was excellent. I then moved to a much larger institution, and since then my success rate has gone down significantly, and I'm just, you know, it just seemed very, very peculiar.
We can look into that. I don't know that we have done that study of large versus small institutions, but that's something
Might
that I
be a
think we have
good
the
idea.
data to look at.
Okay. Thank you. I will say that I'm on a proposal studying Westerland 2, and it's all women, sort of not by accident, but we did get the time, so. And we're coming out pretty soon with some pretty impressive results. So anyway, again, thank you all, and have a good afternoon. Thank you.
Together what it calls a 2020 vision for the observatory, and that 2020 vision is very straightforward and simple. It's to operate the observatory out to 2020 or beyond so that there's at least a year of overlapping science observations with JWST. And that's going to be performed in a manner that maximizes the science return of both observatories, takes full advantages of HST's unique capabilities, and really addresses the community's scientific curiosity and engages the public in scientific discovery. Let's think about that for a minute. If we operate out through the end of fiscal year 21, which is cycle 28, we're currently in cycle 22 right now, that's about 7 cycles of observations. At about 4,000 science orbits per cycle, 4,000 hours per cycle, roughly, that's 28,000 orbits of science remaining. And for comparison, we typically have about 20,000 hours or orbits requested each cycle. There's clearly no loss of things or lack of things to do with this observatory in its remaining years. The question is, what do we do? And so we've put out a call for HST 2020. There's an extra 2 in there, isn't there? You never know. You never know. We put out a call for vision white papers, short white papers from the community, just asking what is it that we should be doing with the observatory over the next 5 or 6 years that would enhance the scientific legacy. Those are due February 20th, and the submission details are there. Those papers can address any aspect of the Hubble program. So I'll put forward a couple of questions to you. Are there specific programs we should be undertaking now in preparation for JWST or during the period of overlap?
Out of that program, and then Amber Straw from NASA headquarters is going to talk to you about the 25th anniversary celebration, the year of activities that are ongoing, and how you can participate. And I will let each speaker hand off to the next. And then at the end, we will have ample time for your questions and discussion. Thank you. So first off will be Ken Sembach on what about HST today and tomorrow.
Thank you, Carol. So yeah, today I'm going to tell you a little bit about where we stand with the observatory today and where we're heading in the next few years. The punchline is this: Hubble is just doing beautifully. It's as powerful as ever. We have excellent imaging and spectroscopy capabilities. We're still doing coronagraphy and astrometry with the telescope. And the observing program is addressing everything from exoplanet science to the architecture of the universe. The science that Hubble does cuts across NASA's main science themes, and as always, Hubble remains a great observatory, multi-purpose, and in wide demand by the observing community. You probably saw this beautiful image on Monday when it was released. This original image of the Eagle Nebula was taken 20 years ago now. Our Wide Field Camera 3 has re-imaged that field, both at visible and at near-infrared wavelengths. And you can see how remarkable that field looks both in the visible with a wider field of view and in the...
So thank you very much for coming for the Hubble Space Telescope Town Hall. You're here to the bitter end, and we're glad to have you here. We're very excited, and I think the whole community should be excited that this marvelous telescope has lasted through to this year, and this begins the 25th year of Hubble Space Telescope operations. Who knew? It's done an amazing amount of science. It's really transformed a lot of the way we do science as well as our thinking on many topics. And so today, as part of the anniversary here at the kickoff proceedings at the AAS, we started with some great press releases, beautiful imagery, and now with the town hall, which is being recorded for posterity, and also if you'd like to share with your friends that we did record this, and we will put it on YouTube so it can be viewed later by those who were not fortunate enough to be here. In this town hall, we're going to have three speakers. First, Ken Sambach from Space Telescope, who is the Hubble Space Telescope mission head. And he's going to review a little bit about where we are with HST and its bright future. Then we're going to have Jennifer Lotz, who's from Space Telescope, who's going to talk to us about our major effort of large observation for the frontier fields. And she's the PI of that program. And some really beautiful data and fantastic results have come.
Infrared, where you can see deep into some of these pillars of star formation. Many of you have probably also seen the tremendous M31 mosaic that's outside the other hall that we have conference talks in. That image is the largest image ever produced by the observatory, both physically printed by the observatory, as well as the largest mosaic we've ever made on the sky, and that was done by Julianne Del Canton and her folks here at the University of Washington, so it was very fitting that we were able to bring that mosaic here to Seattle. Take a look at that. Get your nose up close to that particular image. There are 100 million stars in that image resolved. It's amazing. Hubble's science output continues to be extremely good. This past year was another excellent year with more than 800 papers published based on HST data. We're running right around 800 papers a year or so for the last 4 or 5 years. There have now been almost 13,000 papers published to date based on HST data. And an even more remarkable number is that almost 13,700 different people have published or had their names on HST papers. Think about that for a minute. That's bigger than the size of the AAS for sure. And so, Hubble is definitely touching generations of astronomers. There have been more than 500 PhD theses based on Hubble data, and right now, approximately 40 or 50 people a year have PhD theses published that are based on Hubble data. Overall, the observatory is doing extremely well. The science instruments are all healthy and operating. The Advanced Camera for Survey and the Wide Field Camera 3 both have charge transfer corrections in place for their CCD cameras, which is great because it means that we're actually able to roll back the aging clocks a bit on those cameras. The Cosmic Origin spectrograph sensitivity is still very, very good. We now have very blue modes that get down well below Lyman alpha. The Space Telescope imaging spectrograph is operating well, and as I said before, it's being used for coronagraphy as well as spectroscopy and imaging. On the main systems of the observatory, those are also working well. 5 of the 6 gyros are available for use. We lost 1 gyro back in March of last year, not a surprise. Gyros are not a life-limiting factor for this observatory. We know how to run in a reduced gyro mode should it be necessary. Overall, the thermal control, the data management systems, and so on are all in excellent health. One interesting tidbit, 2 instruments were repaired during the servicing mission 5.5 years ago, the Advanced Camera for Surveys and the Space Telescope Imaging Spectrograph. Those failures that originally occurred were electronic in nature. The astronauts installed new electronics in both instruments. Those 2 new instruments have run now on those newly installed electronics longer than they ran on the original electronics. That's very encouraging because it suggests that the instruments have outlived their infant mortality period. So it's quite possible, even though we originally thought those 2 instruments might not last more than 5 years, they may actually last considerably longer than that. We'll see. In looking forward, the mission has put together